Hello and good morning everyone. So in this video we will be learning about Google Kubernetes Engine. Generally we know it as GKE. GKE is all about Kubernetes services that is provided by Google Cloud. Before going inside the terms and details of GKE, let's understand why we need and why GKE was required, or I would say why Kubernetes was required. So basically, whenever we do any kind of deployments to run our any production services or any our application or web portal or websites, so it happens like there are some scenarios where your application that you have created for or for Linux or any environment, maybe it will not run on any IaaS servers or any other server or any other platform. So first of all, the first thing it provides you is platform independence. It is like you can build once and it can be available to run on every service, every platform, anywhere. So this was the best and core benefit of using GKE. And the other aspects of GKE was, it was kind of fault tolerant. We can say it supports large scale auto scaling. Then, whenever we deploy any Kubernetes service in production, we generally deploy in a scenario in a way like you have multiple replicas, multiple pods running in a cluster, and that cluster will maintain the life of all the available running pods. So it is like near impossible, like your service or your application will go down. So that's a very good thing. I mean, a term we use, fault tolerant. So GKE is a fault tolerant thing. Okay. So there are multiple components inside GKE that actually, help to, provide these features that we just, discussed. So now I will, give you some basic ideas like what terminologies we use and what actually, Kubernetes and GKE. So basically, GKE was, or I would say Kubernetes was a product of Google, and they made it open source. Then it then you know came very popular. Many other organizations or I would say many other entities have created their own versions and used the GKE to create very big and very heavy loaded uh, servers, infrastructures. So this Kubernetes was a game changing when it comes to deployment and running an application. So what's inside a GKE? So let's see. So basically, take an example of a cluster. So what is a cluster? So let's say it's an entire Kubernetes system, all nodes, networking, and the control plane and its components, all the things working together. We call it as a cluster. Okay. So what I could explain it like let's take an example of a city, and that city has a government and its residents both working together to run it. So when I say government, let's say the control plane, And when I say residence, let's say nodes. So they both are working with each other to, keep the cluster running. I will go down with the every aspect. So this thing here that we call as a control plane in the top box. So you can say it as a, the base of this Kubernetes cluster, or I would say brain. So it is something that makes the decision, like what will be scheduled, how it be scaled, and if something goes wrong, how it will be, how it will, overcome to that particular scenario. So it's all been done by this control plane, and generally, if I say not master slave thing, but there are some master nodes available in a cluster, that work as a control plane. Okay, so control plane generally has these four components. The first one is obviously control manager, then the scheduler, and then etcd, and then the API server. So understanding the flow and the working of this control plane, we have to understand the API server. So API server is I would say a gateway. I would say as a gateway for all three components, control manager, scheduler, and etcd, to communicate with the nodes. So I would say uh, it basically, what it does, it whenever a request comes to a cluster, it generally goes to the control plane, and this API server will basically do the validations for that request, and it also updates the status of the cluster in the etcd. Okay, so I will come to etcd later, but it actually stores the statuses and other uh, details about the cluster, and also it gives back the details back to the clients. So let's look into this etcd, what it is. So it is actually a key value pair store, I would say, and that stores all cluster configurations and states. So, which pod are running and what services exist, what are the network settings, all these things are stored in etcd. So it's important part of this control plane to maintain the status, and as a key value store. Okay, so now coming to the control manager. So control manager is a kind of, I would say, a running background loop that generally, watches the cluster state, try to, manages the pods, try to manages the node statuses, ensures the pods are at the correct state, the count of the pods running in each node, or it keep tracks of all the services and the pods that are running inside. So that's a important work of this control manager. So control manager keep tracking the all nodes, pods, and services, and then its data is kind of stored in etcd as a key value pair. So that's a cycle here, and then comes the scheduler. So it's something very important that decides which node, I mean, a new node should run, where a new node should be running, and it's basically keep checking the availability of resources. When I say resources, it means CPU or RAM, and this scheduler basically gives the nodes the ability to start a new pod, uh, create new containers, These abilities are been efficiently provided by the scheduler. So all three components, control manager, scheduler, and etcd, work together to run this whole cluster efficiently. Now look at the important part of this cluster is a node. So there can be multiple nodes, and this is important to understand that control plane itself is a node, but the behavior is different. So when we talk about these nodes where we have pods, so basically you can understand it as a machine in a Kubernetes cluster that runs the workloads. So that's a simple definition. And uh, these are known as worker nodes, okay? Also known as worker nodes, I would say, that actually run the application pods. Your application that is actually running inside the worker node, that is node 1 or node 2 or can be of node n. And there is a master node, and again that's known as control plane. So that's the basic terms that we give when it comes to nodes. So and each node contains pods, then container runtime, and then kubelet and kubeproxy. I will come to these details later, but to understand, this is what makes a node where your pod is running. So if I can explain, like a node is something that do all the things, but it doesn't decide anything. What decides what a node can do is a control plane. Okay, so this is also important to understand. Now, what is a pod? So pod is a smallest deployable unit, like a place where your containers will be deployed, like where your exact code will run. You know, so a pod can have multiple containers. Generally, in productions, we keep two or three, but it depends on the scenarios. But generally, we keep one, two, or three. Like if any container goes down, other will pick up, or any goes down, the other pod will pick up. So it makes the architecture very robust. So again, pod is something where our containers will run, and each container, I would say, or I would say each pod, and each pod, like pod 1, pod 2, can be 4 pods, can be 5 pods. So each pod shares same network and same IP, and so that they can communicate with each other efficiently. So that's an important thing to understand, so that each pod can communicate with each other, and if there are multiple services, microservices, those microservices can communicate with each other on that port, on that same IP, internal IP. So that's important thing when we talk about the communication between the pods. And also they share you know same storage if they have. Now coming to the containers. So containers are, I would say, isolated environments, a very lightweight thing that run a single application, and all the dependencies what is required to run an application are pre-installed, pre-configured in that container. So the container doesn't have to look anything outside. Everything is available inside that container. And generally, when we talk about container engines that are used to run the containers and create containers, are like Docker and CRIO. So these are some engines available. And container runtime is something, I would say, a software. And here I would just explain that we have Docker. So you can say the software or Docker uh, is the one which makes the container runtime, and that actually runs the containers. So that's a container runtime, and the main work of a container runtime is kind of pulling container images from the registries, maybe stopping or starting the container. So this is something achieved using the container runtimes. Now this kubelet and kube proxies are very important component of a node that actually helps somehow in a way to communicate with the control plane. So control plane should be aware about each node, and what action is to be taken by control plane can be efficiently made available to node to every available nodes. So Cube kubelet is a kind of a running, I would say, an agent. I would simply term it as an agent running on each node that talk backs to the control plane, and it ensures that containers, like each container and each pod inside the container are running according to the specifications provided by the control plane. So that's the main thing of it, and it also report back to the you know to the API server about the pod status and the status of the node, like how it's running, so that control plan can decide on according to that. So that's the important part of the node kubelet. And then the kube proxy. So it is actually a network component, I would say, generally related to the network thing. It's a network component running in each pod. It handles the routing of the traffics to the pod. So every request that comes inside the node is been routed, and that traffic is been maintained by the kube proxy. So it has a set of rules. So services, like whatever request is coming, can easily talk to the pods available in the nodes. And in simple terms, I can say every request that is coming inside the coming inside the node is been handled by kube proxy and then redirected to the pods, available pods. So I think this is how a Kubernetes engine works. And there are other basic things, basic components as well, but these are the some main components that is responsible for actually running the GKEs. And also there comes a term that we generally see is node pool. So what are node pool? So these are basically a set of similar configured nodes that has a kind of same configurations and that are available inside a cluster, and those similar or basically a group of nodes with same configurations inside a cluster is known as node pools. What happens when we use node pools? So it becomes easier to manage and scale if your nodes have similar or identical specifications. So now compare the same GKE service provided by Google Cloud with the Amazon Web Services. So in Amazon AWS, we have Elastic Kubernetes Service, and the feature and working are quite same. There are no major differences other than the learning curve. GK is kind of easy and easy to learn, but if you try to learn AWS EKS, it's kind of little difficult, but uh, it's kind of same, but not same when we comes to it comes to learning. It's little difficult. Now, when it comes about the integration, so GCP IAM is integrated via workload identity, and AWS IAM via IAM roles of services account. So that's something important to secure your GKE. So both have their own services that are used to provide you know IAM features. When it comes to CI/CD integrations in the GKE, then there are services like Cloud Build, Cloud Deployed, and Artifact Registry that works together to complete a CI/CD integration. And for AWS, there are different set of services like Code Pipeline, Code Build, and ECR. that are working together to make your EKS deployed. Now, when you talk about the startup time, then GKE has less startup. It's very fast compared to the EKS, but both are very efficient. These are some very minor differences that are kind of negligible. So I think that's all for the GKE and Google Kubernetes Engine. And I think you got a good idea about what GKE is and how it works. But we also have to see the demo part. And in that part, we will see how GKE is actually seen inside Google Cloud, and we will try to explore the features via UI, and if possible we can also try to deploy some GKE applications so you can see it running. So this is all for this video. Thanks for watching this video, and please like and subscribe my video. Thank you so much.